everyone, it's Justin again. In this lesson, we're going to be looking at a specific form of linear equations called slope-intercept form. We'll learn the parts of slope-intercept form and how we can use it to help graph linear equations. Before we start learning together, you have a discovery to complete on your own. In your PDF, you'll find the Algebra activity titled Slope-Intercept Form Exploration. If you haven't yet completed it, pause this video here and go complete the activity now. I'll be waiting for you when you're ready to come back. On GeoGebra, you were working with equations that looked like this. They were all y equals something times x with a constant term. To write this as a general formula or equation, we use m to represent the coefficient of x and b to represent the constant term. And this, y equals mx plus b, is what we call slope-intercept form of linear equations. From our prior lessons, we know that x and y represent the x and y coordinate system. So the question is, what do m and b represent? And how do they affect the line that's created by the equation? You got to discover what m does in exploration number 1. What did you find out? When you change the number in front of x, it affects the direction and steepness of the line. What term do we know describes the direction and steepness of a line? The slope. So in slope-intercept form, m represents the slope of the line. Now what about b? You got to see what b does in exploration number 2. What did you find out? Changing the constant term shifts the line up and down on the coordinate plane. More specifically, b is the y-intercept of the line. We can actually show why this is true using algebra. So the y-intercept has to be on the y-axis. And what do you know about the coordinates of the points that are on the y-axis? Yeah, their x-coordinate has to be 0, which tells us that all y-intercepts look like 0, something. Well, what happens if I substitute 0 for x in the slope-intercept equation? Try it now and find out. When I substitute and simplify, since anything times 0 is 0, I get that the y-coordinate is b, making the y-intercept 0, b. Now that we know what slope-intercept form is, let's see what we can do with it. Slope-intercept form is great for graphing because it has all of the information that we need in one nice, tidy package. Let's take y equals negative 2x minus 3. I can see that this matches my slope-intercept form of y equals mx plus b, so what is m in this equation? M is the coefficient of x, so it's negative 2, which means that the slope of this line is negative 2. Great, we're halfway there. So what's b in this equation? Don't let this minus trip you up. It just means that b is negative 3. So the y-intercept of this line is negative 3, or 0, negative 3. This is actually all we need to be able to graph this entire line. Pause the video here and make a prediction. What do you think we can do with this information to graph the line? Let's check how your ideas match up with mine. Since we know that the y-intercept of this line is 0, negative 3, I can plot that point. I know my line will go through here, but I could plot a lot of lines that go through this point. So how do I know which one it is? I still have my slope. The slope of a line represents the rise and run between its points as a fraction. How can I represent an integer like negative 2 as a fraction? We can put it over 1, so we can write our slope as negative 2 over 1. This means that our rise is negative 2, meaning down 2, and our run is positive 1, meaning right 1. I could start at my y-intercept, a point that we know is on the line, and then use my slope to get to another point on the line. I would go down 2 for the rise and right 1 for the run, which puts another point here. And I can keep going, down 2, right 1, to get another point. I've run out of room on my graph here, but I can also go backwards. If we take our slope and rewrite it by taking the opposite of the numerator and the opposite of the denominator, we get positive 2 over negative 1. This is still equivalent to our original slope, but by writing it in a new way, it lets us think about our slope differently. Instead of going down 2, right 1, I can also go backwards by going up 2 and left 1. This can help me find points on my line on the opposite side of the y-axis like these. These points that we've plotted represent some of the points on this line. To represent all of them, we'll need to draw on the line that connects all of these points, and then add an arrow on both ends to show that it keeps going in both directions. Take a moment to pause the video here and complete the stop and jot in your guided notes to summarize how to graph lines from slope-intercept form. I'm going to hand you over to Jenna now to do one more example problem.
Thanks, Justin. Hey, everyone. Let's do some graphing. Our example problem says to graph y equals negative 1/3 x on the coordinate plane. Okay, no problem. I just need to identify my slope and my y-intercept from my equation. If I compare my equation to y equals mx plus b, then I can see that m, or the slope, is negative 1/3. But my equation doesn't really have a b. There's nothing here. Actually, that's okay. I know that I could add 0 here without actually changing the value of my equation. So my y-intercept, which I'm just going to abbreviate as y-int, is actually 0. Let's start by plotting the y-intercept, and I'm going to do this in blue so that it shows up a little easier on the graph. Where is 0? On the y-axis. It's actually at the origin, so my y-intercept goes right here. Now I can use my slope to find another few points before I draw in the line to connect them. Notice in the original equation that the negative sign was actually beside my fraction of 1/3. But when I wrote it out as my slope, I put the negative sign in the numerator. That just makes it easier for me to understand and see that my rise is going to be down 1 and my run is going to be right 3. So from my y-intercept at the origin, I'm going to go down 1 and right 3. And that puts my next point right here. And I can get rid of my scratch work. Even though I could already connect these 2 points to make a line, it's really best to find at least 3 or 4 points. That way, if you make a mistake on one of them, it'll be a lot easier to tell. So I'll use my slope one more time in this direction. Down 1, right 3, puts my next point right here. I can also go back to my slope and take the opposite of the numerator and the denominator, which would make this a positive 1 over a negative 3. That can help me use my slope to go in the other direction, because now it looks like up 1, left 3. So I can go back to my y-intercept and go up 1 and left 3 to get to another point, which would be here. And why not one more for good measure? Up 1, left 3, and another point goes here. Now I'll just connect them all, and I'll do my best to make my line straight. Once I have my line, I'm going to add an arrow to each end to show that it keeps going forever and ever in both directions. And there's my final graph. Thanks for graphing with me. I'll send you back to Justin now, and I'll see you again soon.
When it comes to graphing linear equations in slope-intercept form, you just need to identify the slope and the y-intercept. Then you can plot the y-intercept as a starting point and use the slope to move along where the line will go to find additional points. Once you have at least 3 points plotted, you can draw on your line to connect them and finish up. Once you finish up your guided notes, you have one more task in your PDF. There's an additional practice section that gives you an opportunity to work more on creating your own linear graphs. And once that's done, you'll finish up this lesson with your practice game. Good luck, and I'll see you next time.
Hey!